TCP/IP protocol suite. Welcome to this presentation on the TCP/IP protocol suite, the foundation of modern internet communication. Today, almost everything we do online, whether it's browsing websites, sending emails, or streaming videos, relies on this powerful set of protocols. TCP/IP is not just a single protocol, but a collection of rules that govern how data is transmitted across networks. It was developed to ensure that computers from different manufacturers and systems can communicate seamlessly. This universality is what made the internet scalable and globally accessible. Think of TCP/IP as the language of the internet. Just like humans need a common language to communicate, computers need TCP/IP to exchange data efficiently and reliably. Throughout this presentation, we'll explore its structure, layers, protocols, and real-world applications. Let's take a step back and understand how networking evolved. Initially, computers operated independently. Over time, the need to share data led to the development of computer networks. Early networking systems were limited and incompatible with each other. The breakthrough came with the development of TCP/IP, which provided a standardized communication framework. This allowed different networks to interconnect, eventually forming what we now call the Internet. TCP/IP became widely adopted because of its flexibility, scalability, and reliability. It replaced earlier experimental protocols and became the backbone of global communication. Today, whether you are using a smartphone, laptop, or server, TCP/IP ensures that all devices can communicate effectively across vast distances. The TCP/IP model consists of four layers, each with a specific role. The network interface layer handles the physical transmission of data, how bits travel over cables or wireless signals. The Internet layer is responsible for addressing and routing. It ensures that data packets reach the correct destination across networks. The transport layer manages reliable communication between the devices. It ensures data arrives correctly and in order. Finally, the application layer interacts directly with users, supporting services like web browsing and email. These layers work together seamlessly, breaking down complex communication into manageable steps. At the top, we have the application layer, which includes protocols users interact with daily. HTTP and HTTPS are used for web browsing. HTTPS adds security through encryption. FTP allows file transfers between systems using commands and responses. The expansion of FTP is File Transfer Protocol. SMTP and POP3 handle email. SMTP sends messages while POP3 retrieves them. SMTP stands for Simple Mail Transfer Protocol and POP3 is Post Office Protocol version 3. DNS or Domain Name System translates human-friendly domain names into IP addresses. Without these protocols, accessing websites, sending emails, or downloading files would not be possible. Let's dive deeper into DNS, the Domain Name System. DNS acts like the phone book of the Internet. Instead of remembering IP addresses, we use domain names like google.com. When you enter a website, DNS translates it into an IP address so your system can locate the server. It follows a hierarchical structure starting from root servers, then top level domain servers, and finally authoritative servers. Caching is also used to speed up the process, reducing lookup time for the frequently accessed sites. Coming to the transport layer, we have two protocols, TCP and UDP. TCP stands for Transmission Control Protocol. It is highly reliable. It uses a three-way handshake, ensuring error correction and guarantees data delivery in order. what do you mean by three-way handshake? So whenever two systems want to interact with one another, the first system will initiate for a transfer, for a communication, asking for an acknowledgement from the destination. This is the first handshake. And the destination system will respond through an acknowledgement, which stands the second step of the three-way handshake. And now the source knows that everything is set for the communication and it starts delivering the data. So this is called as a three-way handshake. UDP, which stands for User Datagram Protocol, on the other hand, is faster but less reliable. It doesn't check for errors or retransmit lost data. So it will transfer the packets or it will transfer the data over the internet connection without any direct communication between the source and the destination. So there is no chance for error checking or retransmission of the data which is lost. TCP is used for applications like file transfers and emails where accuracy becomes very critical. UDP is ideal for streaming and gaming where speed matters the most more than accuracy. Coming on to the internet layer protocols. The internet layer includes key protocols like IP, which stands for Internet Protocol, ICMP, which stands for Internet Control Messaging Protocol, and ARP, Address Resolution Protocol. IP handles addressing and routing. It determines how the packets, that is the data chunks, which will travel across the networks. So IP is going to determine how these packets are going to travel through the network. ICMP is used for diagnostics. Tools like ping and traceroute rely on this protocol. ARP, as the name suggests, will map the IP addresses to the MAC addresses, helping the devices to locate each other within a network. Together, all these protocols ensure efficient and accurate data delivery. Now, we'll have a comparison between IPv4 and IPv6. As we have seen in the previous slide, IP stands for Internet Protocol, IPv4 is Internet Protocol version 4 and IPv6 is Internet Protocol version 6. Now let's go into a comparison between IPv4 and IPv6. IPv4 is using 32-bit addresses and supports about 4.3 billion devices. However, it is running out of available addresses. So there are more number of computers now. So you need lot of IP addresses which cannot be sustained by IPv4. IPv6 solves this problem with 128-bit addressing. It allows an enormous number of devices. IPv6 is more efficient, secure, and future ready. As the number of connected devices grows day by day, IPv6 adoption is becoming increasingly important. Next comes the network interface layer. This layer is going to deal with the actual physical communication. Ethernet is the most common LAN technology using MAC addresses for identification. MAC stands for Medium Access Control. PPP or point-to-point protocol is used for the direct communication between two devices. It includes features like authentication and error detection. This layer ensures that data is properly transmitted over the physical media. So having discussed all the protocols with respect to the TCP/IP model, let us now look into the future of TCP/IP. Looking ahead, TCP/IP continues to evolve. It remains the foundation of global communication, supporting everything from web browsing to cloud services. With emerging technologies like IoT, artificial intelligence, and 5G, TCP/IP is adapting to meet the new demands. Innovation in networking will continue to build on this protocol suite.